writing linear functions. So again, we're still looking at our linear functions, and again, we've talked about different ways that we can represent them, and we should be able to go from one form to another form in any of those patterns as we look at the patterns of our linear function. So from here, we're going to be taking a look at some representations of linear functions and trying to go backwards to figure out what equation describes that particular pattern. So a linear function is a function whose graph is a non-vertical line. It can't be a vertical line on a graph because then we have one input with lots of outputs, so it won't be vertical. A linear function can be written in the form, and this is a very familiar form to us, y equals mx plus b, where m is the slope or the rate of change, and b is the y-intercept or that starting point. So if we're just looking at a graph, m is slope, b is our y-intercept. If we're thinking about a word problem, m is our rate of change, and b is kind of our starting point in the story. Write a linear function that relates y to x. So we're going to write a linear function for each of these graphs. So we're starting with a coordinate plane. We're starting with some ordered pairs here. Now, since we're looking at a graph, we can think about our slope and our y-intercept as they pertain to the graph. So my slope is my rise and my run. Don't forget that, rise over run. We could also use our slope formula, y2 minus y1 equals x over x2 minus x1. But I have a graph in front of me, so I'll use rise and run. So I have a rise of -1 and a run of 2. Rise of -1, run of 2. Rise of -1, run of 2. So that gives me a slope of -1/2. It's a negative pattern there, so that's a negative slope. My y-intercept, I can find that right on my y-axis here. It's at 0, -1. So that's my y-intercept. So I can use my formula and I can plug in my slope and my y-intercept to create an equation. So my slope is -1/2 and my y-intercept is -1. So y equals -1/2 x minus 1, or I could write plus a -1. That would work just fine also. All right, let's take a look at another graph. Again, since it's a graph, I'm going to use my slope and my y-intercept literally from the graph instead of trying to do the math to figure it out. So I see a rise of -3 and a run of 1, a rise of -3 and a run of 1, a rise of -3 and another run of 1. So that gives me a slope of -3 over 1, which is -3. My y-intercept is here on the y-axis. It's 0, 1. So I have a y-intercept of 1. Again, we could tell from the ordered pair because it has a 0 for my x, meaning I didn't go side to side at all. I just went up and down the y-axis. And so going back to my slope-intercept form, y equals mx plus b, I plug in my slope and my y-intercept, and I come up with the equation y equals -3x plus 1. So that's writing a linear function from a graph. Now let's do that same thing from a table. So again, we still want to think about the slope and the y-intercept. So from a table, I can look at a few different things here. I could use, to find my slope, I could use my slope formula, y2 minus y1 over x2 minus x1. Or I could actually just kind of do it on the table here. So if I subtract these, if I do 0 minus 2, 0 minus a -2, that gives me 2. 2 minus 2 gives me 2. 4 minus 2, 2 minus 0 gives me 2. 4 minus 2 also gives me 2. So I'm noticing here that I'm increasing by 2 as I go up here. That's my run. And then my rise, I'm increasing by 1 on my rise. So my rise is going up by 1. My run is going up by 2. So I have a slope of 1/2. Remember, slope is always y over x. So I have a slope of 1/2. My y-intercept, I can find this in the table by looking where x is equal to 0. Because remember, our ordered pair for my y-intercept always has x equals 0. So there is my y-intercept right there, 0 equals -1. So I can take those pieces and I can plug them into my equation, y equals mx plus b. Remember, we can write this as -1, or I could put it as plus a -1. So y equals 1/2 x plus -1. Also perfectly acceptable to write it that way. Let's look at another table here. This one looks a little bit weird, and hopefully, again, bells and whistles are going off in your head at this point, because you're noticing that all the y values are the same, and that should register in your brain somewhere deep in your brain, because we've done those before. But let's go through the same pattern that we did for our first one. So to find my slope, I'm going to think of my run, and I'm going to think of my rise. I have a rise of nothing. My y-axis, I don't go up and down at all. But I do have a run of 1. So I have a run, but I don't have any rise. I'm not going up and down at all. This should sound familiar. So that means I have a slope of 0, which makes sense. I'm not going up and down at all. I'm going straight across. Remember, that's our ski slope where we can ski, and I'm not moving at all. I have a speed of 0. This is a horizontal line. My y-intercept, 0, 2. Here's where it crosses the y-axis at 0, 2. So my equation, if I still go about this, imagining that I don't know what this line looks like and I don't know what this equation is going to look like yet, I say y equals 0x plus 2. 0 times x is 0. 0 plus 2 is 2. So this equation is y equals 2. Again, if we go back to the table, that makes total sense. This equation tells me y has to be 2. Do whatever you want with the x's. So y is always 2. X is whatever we want it to be. So those pieces coming back together again. Our horizontal line, which has a slope of 0. Remember we said a function cannot have be a vertical line because then our input has more than one output, but it can be a horizontal line with a slope of 0. So as we write a function rule from a graph or from a table, we still want to keep thinking about our slope. We still want to keep thinking about our y-intercept.